Hello and welcome to Patch Math, where today we are going to patch your math knowledge on solving trig equations. You'll notice here that they immediately give us a restriction of x. In this case, that is our angle here. It's our angle on our unit circle, usually represented by theta, or more commonly represented as theta. And all that means is that we are restricting our angle from the starting point here. And then we will go from 0 pi over 2 to pi to 3 pi over 2 all the way back to 0, which is also known as 2 pi in radians. And that's all they're asking here. Trigonometric equations. This keeps going. These we have what's called coterminal angles. We can go beyond 2 pi, and we can go down below 0 into negative angles. However, they're making our lives easier here by restricting it. Immediately, I'm going to launch into my equation solving skills in order to isolate my cosine of x there. It's going to allow me to use my unit circle more clearly. I do opposite operation on both sides of the equal sign, and since order of operations is PEMDAS, parentheses, exponent, multiplication and division, and then addition and subtraction, opposite operation is opposite order of operations as that path of least resistance. And so addition and subtraction is the last step in PEMDAS. So in opposite PEMDAS, it is the first step. So we are going to undo that subtraction with addition. That leaves us with square root of 2 times cosine of x. This is angle of x here that is important. Equals 1. We're going to keep on keeping on. That square root of 2 is attached by multiplication. The opposite of multiplication is division. So we are going to divide on both sides of the equal sign. That cancels. And that leaves us with cosine of x equals 1 over square roots of 2. Now we're going to be using our unit circle here, so I'm going to zoom out. Notice that anything that has a square root of 2 in it in the unit circle, the square root of 2 is in the numerator. So what they've done there is they have rationalized the denominators of those fractions, and we're going to need to do the same here so it's clear what exactly we're looking for. If we're going to rationalize the denominator, we're going to use a similar concept of how we modify fractions in order to add or subtract them. Once we find the least common denominator, when we would modify the fraction, you have to multiply the numerator and the denominator by the same thing in order to not change the value of the fraction. Now, the value needs to remain the same here, and that's because we need to multiply by a value of 1. Well, we can easily get square roots to cancel out by multiplying them by, we can easily get square roots to cancel out the denominator by multiplying by the same square root of 2. And because we multiply the denominator by square root of 2, we must also do so in the numerator. And this simplifies to 1, so we're not changing the value, just the way that it looks. With that being said, cosine of x here is equal to square roots of 2 over square roots of 2 times 2. And that's using radical rules there, that we know we can multiply those 2's on the inside of that radical. While simplifying that right-hand side down a little bit, we're going to leave that radical 2 in our numerator. Now our denominator, we have square root of something times itself. It's also the square root of 2 squared Square roots cancel out squares, and that's why we made that choice there, for that reason. We can also look at that as the square root of 4, and we also know the square root of 4 is 2. Moving on, cosine of x equals square roots of 2 over 2. Now notice here our output is positive. And also notice here, we have these ordered pairs on our unit circle. If you're at this point in your math class, you know that your x value on your unit circle stands for your cosine of your angle. And your y value stands for sine of your angle. Now, you'll see why I am representing that as x value and y value explicitly there. And it's because we have an x here in our equation, and that's what we're solving for. But it's a different x than these x over here. It's actually what we more commonly call is theta to represent an angle on the unit circle. So x value is cosine of theta, cosine of an angle. That's the x value of these ordered pairs here. And sine of theta is the y value. All right. Now that we've got that clarified, you'll see that our output is positive. And since cosine is our x value, x's are not positive in the second quadrant, and x's are not positive in the third quadrant. That restricts us to quadrant 1 and quadrant 4. And that adds to that restriction that is given to us in the beginning. All right, so we're not finding coterminal angles here, just between 0 and 2 pi. And then specifically, now we're looking at quadrants 1 and 4. Well, cosine is our x value of our ordered pairs, and square roots of 2 over 2 is the x value for angle 7 pi over 4. Notice that. And square roots of 2 over 2 is our cosine of our angle for pi over 4. So in this case, the x value that represents our angle here, and I get that me specifying that is a mouthful, but totally different x value, super important. And I am rewriting this for no reason because I just need write x equals pi over 4, our angle, and 7 pi over 4, and we are done. Zooming out, that is how you solve trig equations using your unit circle. Thank you so much for your time.